Hey friends, tonight we'll drift together through the gentle hush of our solar system, a place where light takes its time, planets turn without hurry, and minutes feel like starlight sliding across a window. If these soft explorations bring you calm, feel free to like and subscribe whenever it feels right. Tell me in the comments where you're listening from and what hour of the night is keeping you company. Now, dim the room, let a small fan hum, and float with me into this slow, cosmic evening. Imagine darkness before there were nights, an invisible cloud spanning dozens of light years, a quiet mixture of hydrogen, helium, and dust grains born from elder stars. This was the solar nebula. Gravity, patient and unblinking, gathered that cloud inward. As the cloud shrank, it spun fast to conservation of angular momentum, the same principle a skater uses when pulling in their arms. What was once a shapeless mist flattened into a luminous disk, a cosmic vinyl record with a brightening note at its center. In that bright center, pressure rose, temperatures climbed, and atoms began to touch in a new way. Hydrogen fused into helium, 4 million tons of mass transmuted into light each second. That light took a labyrinthine path, hundreds of thousands of years bouncing from particle to particle inside the newborn sun before slipping free in 8 quiet minutes to Earth's future sky. Even now, our star hums with pressure waves, helioseismology's music vibrations that let us read its hidden interior like a stethoscope listens to a heart. Around the sun, the protoplanetary disk glittered with possibilities. Tiny dust grains, silicates, ices, metals collided, stuck, and grew. Static cling became contact. Contact became pebbles. Pebbles became stones. Over millions of years, stones snowballed into kilometer-wide planetesimals. When gravity joined the game, growth quickened. Planetesimals merged into protoplanets, their collisions violent but creative. An orchestra of impacts shaping worlds from the raw syntax of matter. The young disk had neighborhoods. Near the sun, heat drove off volatile ices, leaving rock and metal to build the small, dense terrestrial planets. Farther out, beyond the frost line, ices could persist. There, protoplanets bulked up fast, their gravity strong enough to capture vast envelopes of hydrogen and helium and grow into gas giants. In between and beyond, leftovers kept their distance, becoming the asteroid belt, the Kuiper belt, and if our theories hold, the great spherical hush of the Oort cloud, a distant pantry of comets. Inside each newborn body, internal fires flickered. Accretion released heat. Radioactive isotopes glowed from within. Worlds melted and separated by density differentiation. Heavy iron and nickel sank to form metallic cores. Silicate mantles flowed and cooled. Crusts solidified on top like the skin of a settling lake. Some cores churned and generated magnetic fields, invisible shields against the solar wind. Others quieted or never fully stirred, leaving their surfaces exposed to charged particles and time. Not every path was peaceful. One world the size of Mars likely struck the young Earth, ejecting vapor and rock that circled and became our moon. Elsewhere, Uranus may have been knocked askew, left to roll around the sun like a sleeping giant turned on its side. Triton, now Neptune's largest moon, seems to have been captured from the Kuiper belt, its backward orbit a fossilized surprise. The solar system is a gallery of memories, each orbit a page, each tilt a fingerprint left by the hand of impact and migration. The sun's wind, an outward breath of charged particles, inflated a magnetic bubble around the growing family, the heliosphere. At its boundary, the solar wind presses against the interstellar medium, the way a candle's warm air meets a cool room. That boundary, the heliopause, is not a wall, but a balance point, and beyond it lies the interstellar sea. Even now, Voyagers 1 and 2 sail those waters, their signals taking more than 20 hours to reach us, each transmission a slow heartbeat from the edge. Closer in, the disk thinned and cleared. What remained were lanes and rings where gravity had swept clean paths. In Saturn's realm, an icy masterpiece formed rings broad as the distance from Earth to the Moon, yet thinner than a city skyline. Their brightness comes from water ice, their structure from collisions and the shepherding of moons. All rings, like all weather, are temporary on cosmic scales. Saturns are slowly raining onto the planet, a shimmering snowfall that will one day fade. We often imagine orbital perfection circles smooth as whispers, but the truth is more nuanced. Planets follow ellipses, with the Sun not at the center, but at one focus. This slight eccentricity lends rhythm to seasons and speed, to perihelion and aphelion. Axial tilts add their own music, tipping day lengths and sunlight angles. On Earth, a 23.5-degree lean orchestrates summer and winter. On Uranus, a 98-degree topple composes decades of day and night. The solar system is not a metronome. It is a waltz. Even the Sun is not still. Every 11 years or so, its magnetic field flips north, becomes south. South becomes north. Sunspots bloom and fade. Flares crackle. And the corona, far hotter than the surface below, flares with woven magnetic energy. When streams of solar particles reach Earth, our magnetic field funnels them to the poles, where they collide with atmospheric atoms and paint the sky with auroras. Space weather is weather, too quiet most nights, wondrous on a few. If you listen closely, you may sense the scale of time here. A human lifetime sits like a dewdrop on the edge of a leaf. Planetary ages are the tree, the forest, the valley. Yet the dew and the forest share the same light. The photons that warm your pillow tonight were forged in the same nuclear furnace that lit the first dawn on newborn Earth. To rest beneath that understanding is not to feel small. It is to feel held by continuity, by processes vast yet knowable. And so we begin our journey where beginnings always start, with the breath of a star and the slow choreography of dust learning to become worlds. We will move gently, pausing with each planet, each moon, each ring and shadow. We will keep one eye on the facts, the densities and distances, the cycles and fields, and one eye on the quiet feelings those facts can carry, like lanterns along a river path. For knowledge, here, is not a wall but a window. Wonder is the open latch. Let your shoulders drop. Picture the disk flattening, the sun brightening, the small stones gathering courage. Everything you will meet tonight was once part of the same cloud. Everything you are is starlight rearranged. As you breathe in, think of fusion. As you breathe out, imagine the solar wind carrying your exhale outward, like a tiny comet tail, always pointing away from the light, yet formed by it. We are ready. The nebula has become a home. At the center of our celestial family burns a calm inferno, the sun, the quiet heart that never stops giving. Everything we know, everything we see, every motion of wind or wave on Earth begins here. It is not just a star. It is the rhythm of time itself, beating once every sunrise. When you picture the sun, don't think of it as a flat golden disk in the sky. Imagine instead a colossal sphere of living fire, 1.4 million kilometers wide, boiling and breathing with light. Beneath its glowing surface, the photosphere lies a deep ocean of plasma, roiling like slow thunder. There is no solid ground inside the sun, only layers of gas so hot that atoms fall apart into a sea of free electrons and nuclei. At its very heart, 15 million degrees, and a pressure 100 billion times that of Earth's atmosphere, crush hydrogen into helium. This is nuclear fusion, the sun's eternal heartbeat. Every second, 4 million tons of matter are transformed into pure energy, enough to power human civilization for millions of years. Yet the sun hardly notices the loss. Over billions of years, it has sacrificed less than 1,000th of its total mass. A slow, graceful generosity. The light born in that nuclear furnace begins a long journey outward. It bounces and scatters through dense layers of plasma for hundreds of thousands of years, inching its way to freedom. When it finally escapes the surface, it travels the 150 million kilometers to Earth in just 8 minutes. The light that touches your skin at noon began its voyage long before human civilization existed. If we could listen to the sun, we would hear it singing. Its surface vibrates with sound waves, pressure ripples rising and falling, bouncing through the hot interior like notes echoing in a cathedral. Scientists call this helioseismology, the study of the sun's hidden music. Each oscillation reveals clues about density, composition, and magnetic fields deep within, as if the sun's own song is whispering its secrets across space. And though it seems steady to us, the sun lives in cycles. Every 11 years, it flips its magnetic poles. North becomes south, south becomes north, like a slow, cosmic breath. During these times, sunspots bloom on its surface, dark whirlpools of magnetism larger than Earth. Solar flares erupt like brief tempests, releasing streams of charged particles into space. When those particles meet Earth's magnetic field, they paint the sky with auroras, silent curtains of green, violet, and crimson light that dance at the poles. Yet even in its most active moments, the sun remains a balanced giant. Its gravity pulls inward, while the heat of fusion pushes outward, an endless tug of equilibrium. If gravity ever won, the sun would collapse. If fusion overpowered it, the star would explode. Instead, they hold each other perfectly, creating an enduring peace that has lasted 4.6 billion years. Its outer atmosphere, the corona, shines with ghostly fire during eclipses, stretching millions of kilometers into space. Paradoxically, this layer is far hotter than the surface below 1,000,000 degrees against the photosphere's modest 5,500. Scientists still puzzle over this mystery. Perhaps magnetic waves, rippling like invisible strings, pump energy upward, or perhaps countless microflares, too small to see, heat the corona from below. The result is an aura of white fire, delicate yet deadly, whispering into the solar wind. The solar wind, a continuous stream of charged particles, flows outward from the sun in all directions, filling the solar system with a magnetic breath. It shapes planetary magnetospheres, sculpts comet tails, and defines the outer boundary of the heliosphere, the vast bubble that shields us from cosmic rays. It is, in a way, the sun's spirit, expanding across billions of kilometers, brushing every moon and asteroid with its unseen hand. For all its size, the sun is not eternal. Like every star, it follows a rhythm of birth, maturity, and decline. Right now, it sits in its stable middle age, quietly fusing hydrogen as it has for nearly 5 billion years. But one day, it will exhaust its fuel. When that time comes, it will swell into a red giant, engulfing Mercury and Venus, and painting the sky of Earth with crimson light. For a short while, the sun will grow vast and strange, before shedding its outer layers into space, a glowing shell of gas called a planetary nebula. What remains will be a white dwarf, no larger than Earth but unimaginably dense, cooling slowly for trillions of years. That future lies far ahead, 5 billion years away. For now, the sun is steady. It burns with quiet confidence, a parent whose warmth holds the planets close. Each dawn on Earth, Every shimmer on Mars, every sparkle on Saturn's rings, all are pieces of its light, scattered across the dark. If you could see the solar system from afar, you'd notice that the sun's mass outweighs everything else combined by more than 99%. Every planet, moon, and pebble dances around it, bound by its gravity. We are not separate from it. We are extensions of its motion, held in orbit by invisible threads of energy and time. Think about that for a moment, that every atom in your body was once illuminated by the same sunlight that now burns your skin. Even the calcium in your bones was forged long ago in a star much like this one, before exploding and seeding the cosmos with new materials. The sun is not just our star. It is the heir of many others, a continuation of ancient stellar generations. At twilight, when the light turns gold and the air softens, remember that glow is not simply sunlight scattering through air. It is history. It is hydrogen made into light, light turned into color, color becoming emotion. The same warmth that nourishes the forests and tides is, in truth, the residue of fusion atomic fire translated into comfort. The sun is the axis of our existence, but it is also a reminder of balance of pressure met with resistance, of heat contained by gravity, of brightness arising from compression. It teaches us that even in tension, there can be harmony, that creation itself is often a steady compromise between collapse and expansion. So, as you lie back, perhaps with eyelids heavy and the sound of a distant hum nearby, imagine the sun vast, radiant, and patient breathing through its magnetic cycles, glowing through the quiet vacuum, steady as your pulse. Feel its warmth as something ancient and intimate, both outside you and within, because tonight, as every night, you are wrapped in its light. The star that birthed the world still watches, still hums, still burns softly across the sea of time, the heart of everything. If you were to stand on Mercury, you'd see the sun rising vast and fierce, 3 times larger than it appears from Earth. The sky would be black, but the light would be white-hot, pouring across a landscape of stone and shadow. And when the sun set, the heat would vanish almost instantly, replaced by a chill that could freeze metal. Mercury is the smallest planet, and the closest to our star, a quiet wanderer caught between fire and emptiness. It moves so swiftly around the sun that the ancient Romans named it for the messenger god, the one who could run between worlds. It completes a year in just 88 Earth days, yet its days, one sunrise to the next, last nearly twice that long, stretching for 176 Earth days. On Mercury, the sun rises slowly, climbs high, pauses, then sinks back again in strange looping motions, as if even time here can't decide which direction to move. Its surface is a record of cosmic violence. Craters overlap like ancient scars. Cliffs called scarps run for hundreds of kilometers, formed when the planet's interior cooled and shrank, wrinkling its crust. The landscape is baked and brittle, a fossil of early solar history. There are no clouds, no wind, no rain, only silence. And yet, Mercury gleams faintly blue-gray, as though still dusted with the memory of heat. Unlike Earth, Mercury has almost no atmosphere. Instead, it's wrapped in an exosphere, a ghostly veil of scattered atoms knocked loose from the surface by solar wind and micrometeorite impacts. Sodium, potassium, and oxygen shimmer faintly in this near vacuum, constantly replenished, constantly escaping into space. It's like a breath that never stays, a fragile whisper against the void. And still, in the planet's most permanent shadows, there is ice. At Mercury's poles, deep craters never see sunlight. Temperatures there stay below 170 degrees Celsius, cold enough for water ice to survive for billions of years. Radar reflections confirm these bright patches, frozen water, hidden inside darkness just a few hundred kilometers from the sun's blaze. It's a contradiction only space can host. Fire beside frost, heat beside silence. Mercury's core is enormous, making up about 80% of the planet's radius. Scientists think it's mostly iron and nickel, compressed into a metallic sphere nearly the size of our moon. The reason for this strange anatomy is uncertain. Maybe Mercury was once a larger world, stripped of its outer layers by a colossal impact in the early solar system. Or perhaps it formed so close to the Sun that only the heaviest elements could survive the heat. Whatever the truth, it remains a planet of density and simplicity, a bare metal heart orbiting close to its maker. Despite its small size, Mercury has a faint magnetic field about 1% as strong as Earth's. That means its molten core still stirs, generating weak lines of magnetism that deflect some solar wind. But they're not enough to create auroras or shield an atmosphere. The solar wind scours the surface directly, spraying atoms into space, carving invisible weather on rock. Mercury's orbit holds another secret one that helped prove Einstein's theory of general relativity. For centuries, astronomers noticed that Mercury's closest approach to the Sun, called perihelion, slowly drifted forward in its orbit, a tiny shift that Newton's laws couldn't explain. In 1915, Einstein showed that space-time itself curves around the Sun, and that Mercury, moving deep in this gravitational well, follows that curve like a marble rolling along a warped surface. The tiny precession of its orbit became one of the first confirmations that gravity is not a force pulling through space, but the bending of space itself. Seen from afar, Mercury glides through sunlight almost invisibly, its surface glowing dull gray against the glare. It's a planet of extremes: the hottest days, the coldest nights, the fastest orbit, the slowest rotation. Yet in all that tension, there is balance. Its gravity holds just enough to stay whole. Its motion keeps it from falling into the Sunday. If you could stand there during dawn, the horizon would shimmer silver gray. Above it, the sun would climb in slow motion, growing brighter until the ground glows white. You'd feel nothing, no wind, no sound, just the vibration of light on rock. Dust would hang motionless. Shadows would carve the ground into ink. And when night returned, the stars would come sharp and countless, unblurred by air, stretching from horizon to horizon so close they'd feel like sparks floating just beyond reach. Mercury has no moons to share its orbit, no clouds to soften its light, no oceans to hold its warmth. It is solitude, made solid. But there's something peaceful in that, a kind of cosmic stillness that reminds us what a planet truly is. A rock circling in light, obeying nothing but physics and patience. And as Mercury races endlessly around its star, it tells a story not of life, but of endurance. A world that spins on the edge of annihilation and yet remains whole, silent, loyal, and bright. It is the innermost note in the solar system's symphony, the first pulse in our star's orbiting heart. Take a breath. Imagine standing there, 1 foot in sunlight, 1 in shadow, feeling how close you are to the source of everything, and how small the distance really is between heat and cold, between light and dark. That's Mercury, the messenger of balance, the smallest world, and the one that never stops running. If Mercury is the messenger of the sun's fire, then Venus is its mirror, beautiful, veiled, and unforgiving. From afar, it glows like a pearl. In the morning or evening sky, the brightest object besides the moon. For centuries, people called it the morning star and the evening star, never realizing they were the same world, a planet both close and elusive, forever hidden behind clouds that never clear. Venus is almost Earth's twin in size and mass. If you held the two worlds side by side, You might think they were sisters, born of the same material, shaped by the same processes. But beneath that resemblance lies a profound difference, a divergence that turned one into a cradle of oceans and life, and the other into a furnace wrapped in eternal storm. At the surface, Venus's temperature reaches nearly 465 degrees Celsius, hot enough to melt lead. Its air is a choking mixture of carbon dioxide with clouds of sulfuric acid, dense enough to press down with 90 times the pressure of Earth's atmosphere, the same as standing nearly a kilometer beneath the ocean. A gentle breeze there would feel like a wall of molten air, thick and heavy, dragging heat like syrup. Once, perhaps, Venus was not so cruel. Long ago, it might have had shallow oceans. The sun was dimmer then, its light weaker. But as the star brightened over time, Venus's warmth increased. Water evaporated, and with it came carbon dioxide, a greenhouse gas that trapped more and more heat. The oceans boiled, clouds thickened, and sunlight could no longer escape. The planet spiraled into a runaway greenhouse effect, transforming into the smoldering inferno we know today. Despite its dense atmosphere, Venus spins slowly, agonizingly slowly. One day there lasts 243 Earth days, longer than its year of 225 days. And strangely, it rotates backward. On Venus, the sun rises in the west and sets in the east. Astronomers call this retrograde rotation, and its cause remains uncertain. Perhaps a colossal impact long ago flipped its spin, or tidal forces from the sun gradually turned it over. Whatever the reason, Venus turns to its own rhythm, the slowest and most solitary rotation in the solar system. If you could somehow float high above the surface, above the acid clouds where the air pressure drops and temperatures cool, the view would be breathtaking. Sunlight would diffuse through pale amber haze, and lightning would flash silently below. At this altitude, the atmosphere is gentle, about the same temperature and pressure as on Earth. Some scientists even speculate that robotic or human airships could one day drift there, exploring a calmer layer of this violent world. In the golden clouds of Venus, life as we know it might be impossible, but life as we don't know it, microbial, airborne, and chemical, might just find a way. Beneath the clouds, radar mapping has revealed a surface of volcanic plains, mountains, and fractured ridges. There are more volcanoes here than on any other planet, thousands of them. Some may still be active, releasing bursts of sulfur and heat. The land is broken into tesserae complex, interwoven plateaus that look like a mosaic of ancient crust. Unlike Earth, Venus shows no sign of modern plate tectonics. Its crust doesn't shift or recycle. Instead, the planet may periodically resurface. In catastrophic episodes, when stored heat bursts upward and melts vast regions at once, renewing everything in molten fire. One of the great mysteries of Venus is its missing magnetic field. With a molten core similar in size to Earth's, it should, in theory, generate a protective magnetic shield, but it doesn't. The dynamo inside seems sluggish, perhaps too slow to stir. Without that defense, the solar wind strips away lighter molecules, whittling the upper atmosphere into long comet-like tails of escaping gas. Venus stands naked before the sun, its air and ions swept downstream like silk threads in solar wind. Yet even in its harshness, Venus possesses beauty. Its clouds reflect nearly 70% of all sunlight, making it shine like a jewel through Earth's skies. Early explorers once dreamed of rainforests beneath those clouds, oceans shimmering with alien fish. Instead, probes that landed there, Venera 9, Venera 13, and others found a world orange and silent. The ground, made of crushed basalt, glowed under the dim amber light filtered by the clouds. The horizon shimmered in haze, The air was still, thick as liquid. The probes survived only minutes before their circuits melted. Still, those few minutes gave us our first and only photographs from Venus's surface, ghostly landscapes of alien calm. There is something haunting about Venus. It's Earth, as it might have been under different circumstances, a vision of what happens when climate and chemistry tip beyond return. It reminds us that habitability is fragile, that balance is a fleeting gift. Where Earth breathes through oceans and forests, Venus chokes beneath its own sky, a caution written in stone and acid. But Venus is not just tragedy, it's mystery. The thick clouds hide secrets, yet unsolved strange chemical traces like phosphine that some claim might hint at biological processes, or patterns of superrotation where upper winds circle the planet in just 4 days. Even without life, Venus is alive in motion, in the swirl of its clouds, in the pulses of its atmosphere, in the glimmer of sunlight scattering through sulfur haze. If you close your eyes, you might imagine standing within those clouds, not on the scalded surface, but high above it. The sunlight diffused and gentle, painting everything gold. You'd float weightless, surrounded by stillness and faint thunder, listening to the slow hum of a world that spins backward, wrapped in beauty and danger alike. Venus is the planet of paradoxes, the twin that burned, the mirror that blurred, the reminder that not all brightness means warmth. She glows not because she is kind, but because she reflects the light of another. Her silence is warning and wonder both. As we leave her behind, the sun's light softens. Ahead lies a blue and white marble, our home, the only world we know that breathes and sings. We'll drift there next, through the thin veil of atmosphere and ocean that makes life possible. But before we go, take one last look at Venus, that brilliant star of evening and morning. In her glow is the echo of what Earth could have been, and the reason we cherish what it became. After the molten stillness of Venus, the next world feels like a miracle. Blue, white, green, and gold, a fragile swirl of color suspended in darkness. Earth, the only planet we know that breathes, the only one that sings with oceans, clouds, and living sound. From afar, it looks calm. But up close, it's a world in motion, not chaotic, but rhythmic. Water moves from sea to sky, from cloud to rain, from river to ocean again. Air drifts in invisible currents, warmed by sunlight, cooled by shadow. Continents slide slowly across molten stone. Volcanoes build mountains. Wind grinds them down. The planet turns, leans, wobbles, and breathes all at once. What makes Earth so alive is balance. Distance from the sun, the gift of a magnetic shield, and the quiet partnership with the moon, all of it, combines to create stability in an otherwise unpredictable universe. Our atmosphere holds heat gently, not too much, not too little. Our oceans absorb carbon dioxide and release oxygen through plankton blooms that sparkle like constellations in water. And beneath our feet, something extraordinary stirs. Plate tectonics, vast slabs of crust that glide, collide, and dive back into the mantle. They recycle the planet's surface, regulate temperature, and refresh the crust with minerals and nutrients. No other world we've found does this. Venus and Mars are geologically quiet by comparison, frozen in ancient patterns. Earth alone reshapes itself constantly, an artist forever repainting her canvas. At its heart, deep below layers of stone, lies a metallic engine, a core of iron and nickel, partly molten, spinning like a dynamo. That motion generates Earth's magnetic field, an invisible cocoon that deflects solar wind and cosmic radiation. Without it, our atmosphere would erode, our air would thin, and our seas would boil away like Venus's long ago. The auroras that shimmer at the poles are visible proof of this unseen protection, where the solar wind kisses the magnetic field and turns charged particles into light. Our planet is also a master of rhythm. It tilts at just the right angle, 23.5 degrees, creating seasons that flow like breath. When the northern hemisphere leans toward the sun, warmth spreads through forests and fields. When it leans away, snow settles softly and the air grows still. The balance between day and night, summer and winter, is one of nature's most elegant equations. Earth is the only known place where water exists naturally, in all three forms: solid, liquid, and gas at the surface. Ice caps and glaciers crown the poles. Oceans pulse with tides. Clouds gather and fade. Every raindrop that falls tonight may have once been part of a prehistoric sea, a glacier, or a storm that soaked the first forests. Water here is ancient, recycled endlessly through time, and yet always new. And then there is life. The thin film of the biosphere clings to the surface like breath on glass. In every forest, desert, ocean, and cloud drift, organisms transform sunlight into energy, air into movement, soil into growth. Earth's chemistry hums with self-renewal, carbon exchanged between rock, ocean, and atmosphere, nitrogen fixed by lightning and microbes, oxygen exhaled by green leaves and phytoplankton. It's a planetary metabolism, a slow global heartbeat that has lasted for billions of years. No one knows exactly when life began. Maybe it started in deep-sea hydrothermal vents, where heat and minerals mixed into the first reactions, or perhaps in shallow tidal pools warmed by the sunday. Either way, Earth created the right conditions: warmth, chemistry, water, and time. From single cells came colonies. From colonies came multicellular beings. Each step shaped the air, land, and ocean in return. Even the moon, Earth's constant companion, plays its part. Its gravity pulls on our oceans, creating tides that circulate nutrients and regulate coastal ecosystems. It steadies Earth's rotation, preventing wild swings in climate. It even slows our spin ever so slightly, lengthening days as centuries pass. The moon's soft light, reflected sunlight, is a nightly reminder of how intimately connected all things are. Look at the atmosphere from space, a paper-thin shell of blue. Within that fragile skin lies everything we know: history, language, memory, laughter, all the air ever breathed. Most of Earth's atmosphere is nitrogen, with oxygen and traces of other gases that sustain fire, breath, and cloud. The troposphere, where weather happens, is only about 10 kilometers thick, barely the height of a short drive. Yet within that thin film, storms rage, birds migrate, and sunlight is scattered into the blue we call sky. Even the colors of Earth are alive. The deep blue of oceans comes from sunlight filtered through water, absorbing reds and reflecting short wavelengths. The greens of forests arise from chlorophyll, the pigment that captures sunlight and turns it into sugar. The gold of deserts, the white of clouds, the polar shimmer of ice. Each hue is a reflection of some physical truth turned beautiful. At night, Earth glows faintly. Not just from cities, but from natural luminescence. Lightning flickering in distant storms, algae glowing in coastal waves, auroras breathing green over the poles. From the moon's perspective, our planet is never still. Even in darkness, it pulses with energy, a living marble wrapped in cloudlight and sea song. Sometimes we forget how rare that is. In all our searching, across hundreds of confirmed exoplanets and thousands of candidates, none yet shows the complexity, the warmth, or the delicate balance of home. Earth's habitability is not an accident. It's the slow convergence of cosmic chance and time. the right distance, the right tilt, the right composition, and billions of years of stability. When you breathe in now, the oxygen entering your lungs may have been exhaled by a fern, or freed from ocean plankton under sunlight, or released by a distant forest half a world away. To live on Earth is to be part of that exchange, part of the great atmospheric conversation of life. From orbit, astronauts often describe a strange emotion, not pride, not fear, but tenderness. The realization that every ocean, every mountain, every life they've ever known is contained within that blue circle floating in endless dark. It's called the overview effect, and it changes them forever. So as you rest tonight, imagine that view. The curve of the horizon glowing in dawnlight, thin air shimmering, continents bathed in gold, the heartbeat of lightning flashing in tropical clouds, the whisper of wind crossing the Sahara, the sigh of waves curling around Antarctic ice. It's all one system connected, alive, and quietly breathing. This is Earth, the only known planet where the universe looks back at itself and smiles. High above the breathing world of Earth drifts a silent companion, pale, steadfast, and ancient, the Moon. It moves through our sky like a clock made of stone, measuring tides and months, marking the slow rhythm of our planet's days. To the naked eye, it seems close enough to touch, but it hangs nearly 400,000 kilometers away, a distance so perfect that when it passes before the sun, it can cover it precisely, leaving only a ring of fire. The Moon was born in violence. Over 4 billion years ago, when Earth was still young and molten, a planet-sized body, perhaps as large as Mars, struck it. The collision threw vast plumes of molten rock into orbit. For a time, our skies glowed with a ring of fiery debris. Gravity gathered that material together, cooling it into a single sphere. That sphere became the Moon. In a sense, it's Earth's child, made of the same stone, forged in the same fire. When it first formed, the Moon orbited much closer than it does now, so close that tides would have towered hundreds of meters high. The Earth spun faster then, a day lasting only a few hours. Over billions of years, tidal friction has slowed Earth's rotation and nudged the Moon outward. Even now, it continues to drift away by about 3.8 centimeters each year, a quiet migration through space. Its face is marked with memory. The Maria, those dark plains we see from Earth, are ancient lava seas, once molten and glowing. The bright highlands are older still, battered by countless impacts. Without wind or rain, every crater remains some shallow and soft from eons of dust, others sharp-edged and young, each a record of a collision that echoed across the solar system. The Moon's surface is like a library that never forgets. Walk there, and your footprints would last for millions of years. There is no air to erode them, no water to wash them away. When the Apollo astronauts left their marks, they became part of the Moon's geology, human shadows pressed into alien dust. Those trails, along with a few flags, instruments, and rover tracks, will remain long after our cities have weathered to sand. Despite its silence, the Moon speaks through motion. Its gravity tugs at Earth's oceans, drawing them gently toward it. As the planet spins, this pull sweeps around the globe, creating the daily rise and fall of tides. On one side of Earth, water bulges toward the Moon. On the opposite side, inertia creates another bulge. The result is a rhythmic breathing of the seas, high and low, inhale and exhale driven by lunar gravity. Tides are not just a curiosity, they are a force of creation. In shallow coastal zones, where the sea retreats and returns, early life may have found the rhythm it needed to evolve cycles of wet and dry, warmth and cool, exposure and shelter. Over time, This tidal heartbeat helped shape the planet's ecosystems, sculpted shorelines, and even guided the migration of species. The moon's pull became a planetary metronome for the dance of life. The moon also stabilizes Earth's axial tilt. Without it, our planet might wobble wildly, causing chaotic shifts in climate. The steady presence of the moon keeps Earth's seasons mild and predictable, anchoring the rhythm of life over eons. In that sense, it's not just a companion, it's a guardian. But the moon has its own quiet dynamism. It experiences moonquakes, tremors triggered by Earth's tides, by thermal expansion as the surface heats and cools, and by distant meteor impacts. Some quakes last for up to an hour, their vibrations echoing through the lunar crust. Though there are no tectonic plates here, the moon is not entirely dead. It moves and flexes, sighs and settles. From Earth, the moon always shows the same face. It is tidally locked, rotating once for each orbit, so one hemisphere, the near side, forever faces us, while the far side remains hidden, revealed only to spacecraft. This dark side isn't truly dark. It receives sunlight as often as the near side, but its surface is rougher, more cratered, marked by fewer basalt plains. It's a glimpse into the unshielded past, the half of the moon that has faced the cosmos without reprieve. Stand on its surface, and the sky would be black even at noon. The sun would blaze without atmosphere, shadows sharp as knives. In that shadow, Earth would hang in the sky, large, bright and blue, turning slowly. You'd see continents drift by, clouds swirl, lightning flash in miniature. Earthlight would bathe the moon's dust in faint color, soft blues and whites that make the lunar night glow. No astronaut who has seen it forgets that sight, a living world floating above a dead one. Yet the moon is not just barren stone. It carries the story of our beginnings and perhaps our future. Its rocks preserve records of the early solar system, untouched by air or erosion. Its polar craters, eternally shadowed, contain water ice relics of ancient comets, potential fuel for explorers. The moon may one day become a harbor again, a stepping stone for journeys outward, the first chapter of humanity's return to the wider cosmos. Culturally too, the moon has never left us. Every civilization has looked up at it and found meaning: gods, calendars, myths, and poems. It marks our festivals, guides our crops, and shapes our sleep. It is woven into the rhythm of human life as deeply as into the rhythm of the tides. When you look at it tonight, perhaps through a window, perhaps just before sleep, think of it not as distant, but as kin. Its light, though only reflected sunlight, is centuries deep in human memory. Its phases are our calendar, its gravity, our quiet heartbeat, and when its reflection shimmers across the ocean, know that it is pulling that very water toward itself, the same pull that shaped the first shores, that steadies Earth's spin, that will continue long after we are gone. The moon is both mirror and metronome, a reminder that even in space, companionship is possible. So let your thoughts drift with it for a while, the tide of your own breath rising and falling like the sea. The moon will keep watch. It always has. If Earth is a song of life, then Mars is its echo, a softer, quieter refrain of what might have been. The red planet glows in the night sky like an ember slowly cooling, its faint light a promise and a memory. To ancient eyes, it was the god of war. To modern ones, it is the dream of exploration, a world both hauntingly familiar and profoundly alien. Mars is smaller than Earth, only about half its diameter, but its landscapes are vast beyond imagination. Rust-colored deserts stretch for thousands of kilometers, painted in hues of ochre, bronze, and gold. The color comes from iron oxide rust, coating its dust and rocks. Over billions of years, that dust has been swept by storms that can engulf the entire planet, turning the thin sky into a swirling haze. Yet even through that haze, the horizon glows softly pink, the light of a distant sun scattered through a fragile atmosphere. The air of Mars is thin, less than 1% of Earth's pressure, mostly carbon dioxide with traces of nitrogen and argon. You could not breathe it, nor would it carry your voice far. There is no ozone to filter sunlight, no thick clouds to blanket heat. Temperatures swing wildly between day and night, from a mild 20 degrees Celsius at noon near the equator to below 100 degrees Celsius by midnight. On Mars, warmth is temporary and silence is absolute. But the surface tells a deeper story, one written in stone and time. Across its equator yawns Valles Marineris, a canyon system so immense it could stretch across the entire continental United States. Some parts plunge more than 7 kilometers deep, 5 times the depth of the Grand Canyon. Scientists believe it formed when the planet's crust stretched and cracked long ago, widened by erosion and landslides. Its walls reveal layers of Martian history, ancient lava flows, dust storms, and the fingerprints of vanished water. Water, that elusive thread of life, once shaped this world. Dry riverbeds curve across the plains. Deltas and lake basins lie fossilized in red rock. Minerals like hematite and clay form only in the presence of water, proof that Mars was once warm enough for rain and rivers. Billions of years ago, it may have had shallow seas, clouds, and even a climate not so different from early Earth's. Then something changed. Mars lost its magnetic field, the shield that once protected its atmosphere from solar wind. Without it, the air was stripped away molecule by molecule. As pressure fell, water boiled and evaporated into space or froze beneath the soil. The surface dried, the temperatures plunged, and the rivers vanished. What remains is a memory of motion. Dry channels that once sang with flow, now silent and red. Still, Mars isn't entirely lifeless. Ice caps made of water and carbon dioxide wax and wane with the seasons, and beneath the surface, hidden reservoirs of frozen water stretch for miles. Some craters and polar regions may conceal subsurface brines, salty liquid water kept from freezing by pressure and chemistry. It's here, scientists believe, that microbial life might still hide, not flourishing, but enduring, waiting for warmth. And Mars is far from geologically dead. Olympus Mons, the tallest volcano in the solar system, rises nearly 22 kilometers high, almost 3 times the height of Everest. Its base spans the size of France. It grew so large because Mars has no plate tectonics. Magma kept rising in the same spot for millions of years, piling layer upon layer of cooled lava. Even now, though it slumbers, Olympus Mons stands like a monument to persistence, a mountain that took eternity to breathe once and then fell silent. Mars also has weather thin, subtle, and persistent. Dust devils twist across the plains, sometimes miles tall but nearly weightless. Frost gathers overnight, melting by morning light. And every few years, storms bloom across the planet and grow until they enshroud it completely, dimming the sun for weeks. It was such a storm in 2018 that ended the long journey of the Opportunity rover, covering its solar panels with dust and leaving it to sleep beneath an ochre sky. Despite the harshness, Mars is a world of beauty. At dawn, its sky glows butterscotch and blue. At night, its 2 small moons, Phobos and Deimos, trace fast arcs overhead. They're not round, but lumpy and irregular, likely captured asteroids. Phobos, the closer one, orbits so near that it rises and sets twice each Martian day, and it's gradually spiraling inward. One day, it will break apart or crash into the planet, scattering into a brief ring of dust before fading away. To human eyes, Mars is strangely familiar. Its valleys, dunes, and horizons resemble deserts on Earth. Its sunlight, though weaker, still casts sharp shadows. Robots have roamed its surface. Spirit, opportunity, curiosity, perseverance. Each one a mechanical pilgrim, each sending back images that look almost like home. Rocks sculpted by wind, hills in the distance, tire tracks in red soil. Every frame feels like déjà vu from another lifetime. Mars also has seasons, shaped by an axial tilt of about 25 degrees, close to Earth's. Ice caps grow and shrink, and the planet breathes carbon dioxide in and out of its thin atmosphere. When spring returns to the poles, sublimating ice releases gas in ghostly jets that carve spider-like patterns into the ground, the planet exhaling as sunlight returns. And perhaps most hauntingly, Mars has sound. When microphones aboard Perseverance recorded the wind for the first time, the audio was faint, a low, whispering sigh across empty land. That breath of Martian air, soft and thin, was the first sound ever heard from another planet. In it, we recognized both distance and connection, a reminder that even silence has a voice. So tonight, as you imagine drifting there, picture yourself standing at the rim of Olympus Mons, the horizon curving away under salmon-colored clouds. The sun is small, but bright. The air barely moves. Far below, the shadows stretch across plains that haven't known rain for billions of years. You could whisper, but the air wouldn't carry it. And yet, in that stillness, you'd feel something familiar, the faint hum of a planet that once dreamed of rivers, still turning quietly through space. Mars may sleep now, but it is not gone. Beneath its frozen soil, warmth lingers. In its red dust lie the elements of life. And in its thin skies, humanity sees its reflection, the echo of its own curiosity, its own loneliness, its own hope to begin again. Between Mars and Jupiter lies a quiet expanse, not empty, but scattered. A cosmic meadow filled with fragments of stone and metal, drifting endlessly around the Sunday. This is the asteroid belt, a realm of forgotten beginnings. To cross it, a spacecraft would not need to weave through crowds of rocks as the old science fiction movies suggest. In truth, the asteroids are separated by vast distances, millions of kilometers apart each one, a lonely traveler circling in silence. The belt is a boundary between two worlds, the inner system of rocky planets and the outer kingdom of gas giants. Long ago, it might have become another planet itself. But Jupiter's immense gravity stirred the region too fiercely, preventing material from ever gathering into a single world. Instead, the remnants of that failed creation remained adrift, frozen mid-formation fragments of what might have been. Most asteroids are irregular, their shapes sculpted by collisions and time. Some are solid metal, the stripped cores of once larger bodies. Others are loose piles of rubble fragments held together by gravity alone, fragile as sandcastles in space. When two collide, they may shatter again, sending smaller pieces into new orbits. Over billions of years, this slow attrition has created a family of countless members, each a shard of ancient memory. Among them are giants. Ceres, nearly 1,000 kilometers wide, is large enough to have pulled itself into a sphere, making it both an asteroid and a dwarf planet. Its surface is dusty and pale, pocked with bright salt deposits that gleam like stars when sunlight strikes them. These glimmers are the traces of briny water that once seeped upward from below, hints that Ceres may still conceal frozen reservoirs or slushy pockets beneath its crust. Then there is Vesta, another world of its own kind, the second largest asteroid, with a dense metallic core and basaltic crust. Vesta once burned with internal heat, forming mountains and volcanic plains. A massive impact, billions of years ago, carved a vast crater at its south pole, scattering debris across the belt. Some of that debris has fallen to Earth, as meteorites, literal pieces of Vesta, resting now in human hands. Most asteroids, though, are small stones, no larger than mountains, some no bigger than boulders. Yet even these tiny wanderers can have moons of their own. The Galileo spacecraft, passing the asteroid Ida in 1993, discovered a small companion named Dactyl, a miniature moon orbiting a rock barely 60 kilometers wide. Since then, astronomers have found dozens more asteroid moons, proving that even in the smallest systems, gravity builds relationships. As sunlight strikes these bodies, they glow faintly, reflecting the ancient colors of the early solar system: gray, bronze, red. Each one tells a different story. Some are rich in carbon compounds, preserving the chemistry of the nebula that birthed the planets. Others are heavy with metal, perhaps remnants of shattered cores from protoplanets destroyed in violent collisions. Together, they are the solar system's archive fossils of formation, untouched by weather or time. Between the asteroids lies dust, a delicate fog of micrometeoroids that glints when sunlight catches it, forming the zodiacal light we sometimes see from Earth just before dawn or after dusk. It looks like a pale, triangular glow, rising from the horizon sunlight, scattered by the debris of creation, a ghost of the solar system's birth, still lingering in the airless dark. The asteroid belt is not lifeless, only quiet. Within its scattered rocks are clues to everything: the origins of water on Earth, the seeds of carbon that may have led to life, and the violent processes that shaped the planets. Some meteorites that fall to Earth contain amino acids, the basic building blocks of biology forged not in oceans or atmospheres, but in cold, dark stone. In a sense, life's chemistry was written here first, long before Earth began to breathe. Jupiter's gravitational might both guards and threatens this region. It shepherds some asteroids into stable families, clusters that share similar orbits and histories, while flinging others into new paths. Occasionally, one of these displaced bodies crosses Earth's orbit, becoming a near-Earth asteroid. Some pass quietly, others collide, as they have many times in the past, leaving craters and consequences. 66 million years ago, such an object ended the age of the dinosaurs. In that moment, a rock from the belt reshaped the history of life. Still, the belt endures unchanging, yet dynamic, a cosmic equilibrium of motion and solitude. It's not chaos, it's choreography. Each rock, no matter how small, follows its own line in an endless, invisible dance around the Sunday. For spacecraft, the belt is both a graveyard and a highway. Dawn visited Vesta and Ceres, gliding gently through these drifting relics. Hayabusa 2 and OSIRIS-REx touched asteroids closer to Earth, collecting grains of ancient dust and bringing them home, the first material samples from the dawn of the solar system. When scientists examined them, they found water-bearing minerals and complex carbon chains, reminders that life on Earth may owe its spark to the messengers of this forgotten belt. If you were floating there now, far from any planet, the stars would be brilliant, unblurred, eternal. You might see Jupiter glowing on one side, Mars faintly red on the other. Between them, small rocks would drift, slow as ours, quiet as thought. There would be no sound, no air, no motion, except your own. Yet all around you, unseen forces would be at work: gravity, light, time guiding each fragment on its patient orbit. The asteroid belt is often called a boundary, but in truth, it's a bridge, a link between the terrestrial and the giant, between what is solid and what is gaseous, between the memory of creation and the future of exploration. It is what remains when a world does not form, and what survives when worlds collide. As we drift onward, Leaving this stony silence behind, we move toward the first of the giants, a planet so large that it bends not only orbits but destinies. Beyond the belt waits Jupiter, the roaring heart of the outer solar system, the guardian and the storm. Beyond the belt of forgotten worlds, the sun's light softens, turning from blazing gold to a gentler bronze. There, in the wide cold of the outer solar system, rises a planet so vast that it could swallow every other world and still have room to spare. Jupiter, the giant among giants. To call Jupiter a planet almost feels too small. It's a system unto itself, a colossal sphere of swirling gas and storms, 1,300 times larger than Earth by volume, and yet made mostly of the same elements as the Sun, hydrogen and helium. It is what the Sun might have been, had it gathered just a little more mass, the star that almost was. From afar, Jupiter's appearance is mesmerizing. Bands of cream, bronze, and crimson circling its equator like painted brushstrokes. These are not merely clouds, but layers of ammonia and water vapor whipped by jet streams that race in opposite directions. Between them, storms form and vanish, each one larger than continents. The atmosphere is in constant motion, an unending symphony of turbulence and flow. And then there is the Great Red Spot, a storm so massive it could engulf 2 or even 3 Earths, swirling for centuries. First observed in the 1600s, it has raged ever since, its winds reaching speeds of over 400 kilometers per hour. No one knows exactly why it endures. Some think it draws strength from heat rising deep below. Others from Jupiter's complex atmospheric chemistry. But to look at it is to see power made visible, a vast hurricane carved into eternity. Jupiter doesn't just reflect sunlight. It glows with its own heat. When it formed, gravity compressed it so fiercely that it still radiates more energy than it receives from the Sunday. That heat stirs its deep layers, fueling the planet's storms and keeping its atmosphere restless. In the infrared spectrum, Jupiter shines like a coal, beneath a thin veil of cloud, a slow-burning furnace adrift in the dark. Though made mostly of gas, Jupiter has a core, perhaps a dense sphere of rock, metal, and exotic ice buried under tens of thousands of kilometers of hydrogen compressed into liquid, and then into something stranger still, metallic hydrogen, a form of matter that conducts electricity like a metal, yet flows like a liquid. This churning metallic layer powers a magnetic field so enormous that it would appear in Earth's sky larger than the Sun if it were visible. That field traps charged particles in radiation belts 1,000 times stronger than Earth's, creating a deadly halo of invisible energy. Spacecraft passing close to Jupiter must carry heavy shielding or risk being fried in hours. Even its moons feel this invisible fury. They are bathed in radiation so intense that it sculpts their surfaces, etching the planet's magnetism into their icy skin. And those moons, there are many. Over 90 have been found so far, from tiny captured rocks to vast worlds that could be planets in their own right. The 4 largest, Io, Europa, Ganymede, and Callisto, are called the Galilean moons, named for Galileo, who first glimpsed them through his telescope in 1610. They were the first proof that not everything revolved around Earth, a revelation that changed humanity's place in the cosmos. Each of those moons is a world of wonder. Io, closest to the planet, is tortured by gravity squeezed and stretched by Jupiter's immense pull until its interior boils. Its surface erupts with volcanoes that fling sulfur hundreds of kilometers high, painting the moon yellow and black. Europa, farther out, hides an ocean of liquid water beneath its frozen crust, kept warm by the same tidal flexing that torments Io. Beneath that ocean, life could exist, not sunlight life, but heat life, nourished by chemical energy from hydrothermal vents, just as it does deep in Earth's seas. Ganymede, the largest moon in the solar system, is bigger than Mercury and has its own magnetic field, the only moon known to do so. Its surface is etched with icy scars and ancient ridges, evidence of shifting ice plates. Callisto, farthest of the four, is heavily cratered and seemingly quiet, yet even it may hide a buried ocean under its crust, a silent sea sealed in darkness. Together, these moons form a miniature solar system, a family of volcanic fire, frozen oceans, and magnetic light, all orbiting a single planet that hums with gravity. The entire system moves like a dance, Io whipping around Jupiter in less than 2 days, Europa every 3.5, Ganymede every 7, and Callisto every 16. Their resonances lock them in rhythm, like musical notes tuned to the same key. Jupiter's gravity extends far beyond the orbits of its moons. It shapes the paths of comets and asteroids, deflecting many that might otherwise strike Earth. In that way, it is both a guardian and a gatekeeper, its enormous presence protecting the inner worlds while occasionally hurling debris inward to remind us of our fragility. Sometimes, comets fall toward Jupiter and meet their end. In 1994, astronomers watched Comet Shoemaker-Levy 9 shatter and plunge into the planet's atmosphere, leaving dark scars larger than Earth. The sight was both humbling and beautiful, a reminder of cosmic scale, of how even destruction can paint briefly in light. Despite its enormity, Jupiter spins with astonishing speed. A day there lasts less than 10 hours, the fastest rotation of any planet. This rapid spin flattens its poles and stretches its equator, driving vast currents that feed its storms. Deep inside, layers of liquid hydrogen churn in endless motion, a rhythm older than life, older than stone. To imagine standing there is to imagine standing on a cloud impossible, yet tempting. There is no solid ground, only increasing pressure, until gas turns to liquid and liquid to metallic storm. If you could float just above the clouds, you'd see ribbons of color rippling like silk, lightning flashing silently across the night side, auroras glowing at the poles, not green and red as on Earth, but ultraviolet and violet, swirling in arcs of magnetic fire. Jupiter is noise and motion, power and patience. It has endured since the beginning, a colossal anchor that holds the solar system in its gravitational embrace. Without it, the orbits of other worlds would drift and destabilize. With it, balance endures. So, as we drift away from this roaring monarch, look back once more at its painted clouds, each a storm, each a story of wind and chemistry. Beneath them lies depth we cannot yet fathom. Above them, moons that whisper of water and time. Jupiter is both protector and destroyer, the beating drum at the heart of the outer solar system. Ahead, another jewel awaits Saturn, the ringed poet of the dark, shimmering with ice and light. Where Jupiter rages, Saturn dreams. We'll visit it next and listen to the soft music of its rings. If Jupiter is the thunder of creation, Saturn is its echo, calm, symmetrical, and filled with quiet grace. Where Jupiter shouts, Saturn whispers. Where Jupiter burns with storm and fire, Saturn gleams like a frozen melody, a vast golden lantern adrift in the outer dark. Seen through a telescope, Saturn takes your breath away. Even small lenses reveal the shimmering halo that makes it one of the most haunting sights in the night sky. Those rings thin as a whisper, yet wide enough to stretch from Earth to the moon circle. The planet, like the grooves of a celestial record, carved by gravity and time. They shine softly, reflecting sunlight like powdered glass scattered in the dark. Each ring is not solid, but made of countless particles, fragments of ice and rock, ranging from dust grains to boulders the size of houses. Together they form a disk only about 100 meters thick, thinner than a city block, but spanning over 280,000 kilometers. From far away they look perfect and continuous, but up close they are turbulent, braided, rippled, and sculpted by invisible forces. Tiny shepherd moons drift among them, their gravity shaping edges, creating gaps, waves, and resonant patterns. The rings are dynamic. They shimmer, flex, and even sing. When spacecraft passed through them, instruments detected vibrations like soft harmonic notes, Saturn's quiet music, played in ice. Scientists believe the rings are young, perhaps less than 100 million years old, a recent addition in cosmic terms. They may have formed from the remains of a shattered moon, torn apart by Saturn's gravity, or from icy debris left over from the planet's formation. Yet, even these timeless circles are not forever. The rings are slowly falling inward, pulled down by gravity and magnetic drag in a process called ring rain. In another few 100 million years, they may fade completely, a masterpiece dissolving back into the void. But Saturn is more than its rings. Beneath that beauty lies power and depth, a world of hydrogen and helium, like Jupiter, but colder, calmer, and paler. The planet's subtle golden hue comes from trace gases and hazes that tint its upper atmosphere. Bands of cloud drift across its surface, slower and gentler than Jupiter's, though storms still rise, vast systems of lightning and turbulence that can rage for months. One such storm, the Great White Spot, appears roughly once every Saturnian year, about every 30 Earth years. When it erupts, it wraps the planet in a bright, swirling cloud, so large it can be seen from Earth with a modest telescope. And then, as quickly as it came, it fades, leaving faint scars in the atmosphere, like the memory of a song. At Saturn's North Pole, something extraordinary happens. The winds there organize themselves into a vast, geometric storm, a perfect hexagon spanning 30,000 kilometers across. 6 sides, endlessly spinning, locked in symmetry. The phenomenon defies simple explanation, but laboratory experiments with rotating fluids have reproduced similar shapes, standing waves created by alternating bands of wind. Still, to see a geometric storm encircling a pole is to glimpse nature performing mathematics. Saturn, like Jupiter, glows faintly with its own internal heat, releasing more energy than it receives from the sunday. Deep inside, metallic hydrogen churns above a rocky core, generating a magnetic field and auroras that shimmer at its poles. These auroras are electric blue and ultraviolet, curling like silk around the planet's shadowed edges. If you were near them, they would light the clouds in ghostly ribbons, bright enough to cast shadows. Saturn's day lasts just over 10 hours, but its year one full orbit around the Sun lasts nearly 30 Earth years. That means each season stretches for more than 7 Earth years. In the long Saturnian winter, sunlight barely reaches its northern hemisphere. When spring finally arrives, sunlight catches the rings at a new angle, changing their glow from silvery white to a warm amber. The planet itself seems to breathe with the rhythm of its seasons. And then there are its moons, more than 80 known companions, each a miniature world. Among them shines Titan, Saturn's largest, bigger than the planet Mercury, and cloaked in a thick orange haze. Titan is the only moon in the solar system with a dense atmosphere and liquid lakes on its surface, but not of water. Instead, its rivers and seas are made of liquid methane and ethane, flowing slowly through a frozen landscape. If you stood on Titan's surface, the sky would be golden and dim, the air thick and heavy. You'd see smooth plains, dunes sculpted by alien winds, and mirror-like lakes reflecting a distant sunday. Rain would fall cold, Hydrocarbon rain and drip into pools that feed methane rivers winding toward Black Seas. It is an Earth-like world built from different chemistry, where carbon and hydrogen dance instead of oxygen and water. Beneath Titan's crust, there may be another ocean, a hidden layer of water mixed with ammonia, warm enough to stay liquid. Another moon, Enceladus, is smaller, barely 500 kilometers wide, yet more astonishing still. From cracks near its south pole, geysers erupt, spraying water vapor and ice crystals into space. These plumes, discovered by the Cassini spacecraft, contain salts, organic compounds, and traces of heat signs of a subsurface ocean beneath the icy shell. Some of the material from these geysers escapes Saturn's gravity and forms part of the planet's E-ring, creating a physical bridge between moon and planet, an exchange of matter written in water. These moons, Titan, Enceladus, Rhea, Dione, Mimas, are not just satellites. They are a constellation of possibilities. Each holds clues to chemistry, habitability, and the ancient processes that shaped the solar system. Saturn gathers them, like a storyteller collects myths, each one different, each one part of the same song. If you could float above Saturn's rings, you'd see sunlight scattering off billions of icy fragments, casting rainbows through the thin arcs. Shadows of moons would drift slowly across the clouds below, and the rings themselves would hum faintly under the passage of magnetic waves. The scene would feel impossibly peaceful motion and stillness in perfect balance. Saturn reminds us that the universe can be both powerful and gentle. It doesn't need to shout to be magnificent. Its rings, its symmetry, its moonlit seas, all whisper of cosmic elegance, of beauty that does not demand attention but simply exists, infinite and serene. And yet, like all beauty, it is temporary. The rings will fall, the storms will fade, but tonight they still shine, circling a planet that glows softly against the black. For now, Saturn sings, and we listen. Next, we drift farther outward beyond the golden planet's embrace, into the realm of the ice giants, Uranus and Neptune, where sunlight fades to twilight and the winds reach the speed of sound. Far beyond Saturn's soft golden glow, sunlight grows thin and cold. It travels for nearly 3 billion kilometers before reaching the next planet, a pale, mysterious world tilted almost completely on its side. This is Uranus, the quietest of giants, a planet that rolls through space like a sleeping marble bathed in icy light. At first glance, Uranus appears simple, a soft sphere of pale cyan and gentle haze, calm and featureless. But beneath that calm lies strangeness. Uranus is unique among all planets. Its axis of rotation is tilted 98 degrees, meaning it doesn't spin upright like a top, but sideways, almost lying flat as it orbits the Sunday. Its poles point nearly directly toward the Sun for part of its year, so each hemisphere experiences 42 years of daylight, followed by 42 years of darkness. It is a planet of long twilight, half a lifetime in sunrise, half in sunset. Why it tilted remains uncertain. Perhaps long ago, Uranus was struck by a massive object, a world-sized impact that knocked it askew and altered its destiny forever. The same event may have helped form its moons and faint rings, remnants of the collision still orbiting today. Whatever the cause, Uranus drifts now as the solar system's most eccentric dreamer, rolling along its path with quiet defiance. Uranus is an ice giant, smaller than Jupiter or Saturn, but still immense, 4 times wider than Earth. Its mass is mostly made of icy water, methane, and ammonia, mixed with hydrogen and helium. Methane gas in its upper atmosphere absorbs red light, reflecting only blue and green, giving Uranus its soft turquoise hue. When sunlight touches it, the planet seems to glow faintly, like a frozen ocean illuminated from within. Despite its gentle appearance, Uranus harbors fierce winds, over 900 kilometers per hour, sweeping through its upper atmosphere in steady, unseen streams. Yet the planet's rotation, lasting just 17 hours, is too slow to whip up massive storms like Jupiter's. Instead, its weather feels like a low, eternal hum, continuous motion without violence, like a deep cosmic sigh. For centuries, Uranus hid from human eyes, mistaken for a distant star. It wasn't until 1781 that astronomer William Herschel, peering through his telescope, realized it was a planet. It was the first new world discovered in modern times, a revelation that expanded the boundaries of the known solar system and hinted that there might be more waiting beyond. That night, the sky became a little larger. Uranus is encircled by 13 faint rings, discovered much later in 1977. They are dark, thin, and subtle, composed of fine dust and icy fragments, some shepherded by small moons. Because of Uranus's extreme tilt, these rings sometimes appear vertical when viewed from Earth, rising like luminous blades through space. They cast delicate shadows on the planet's clouds, a quiet geometry carved by gravity. And then there are the moons, at least 27 known so far, each named not from mythology, but from the works of Shakespeare and Alexander Pope. They are characters from human imagination, orbiting a world of ice: Titania, Oberon, Ariel, Umbriel, Miranda. Each moon is small and strange. Miranda, the closest, looks as though it has been shattered and reassembled, its surface scarred by cliffs taller than Mount Everest. It may once have broken apart completely and reformed under gravity's pull, a world reborn from its own ruins. Titania and Oberon, the largest, show canyons hundreds of kilometers long, signs of tectonic stretching and internal change. Beneath their crusts, there may even be hidden oceans, warmed slightly by the decay of radioactive elements deep below. The Voyager 2 spacecraft, passing Uranus in 1986, revealed these wonders in brief flashes, pale images sent across billions of kilometers. For just a few hours, humanity glimpsed this sideways planet up close, and then it was gone again, shrinking back into the darkness. No spacecraft has returned since. Uranus remains one of the least explored worlds. We know an unvisited enigma, quietly turning in the cold, yet its influence is vast. Uranus's magnetic field, like its spin, is tilted off-center and unpredictable, creating auroras that wander across the planet's surface in strange, uneven paths. These ghostly lights shimmer in greens and violets, visible only through instruments, tracing lines of energy through an atmosphere colder than any freezer on Earth, as low as 224 degrees Celsius, making Uranus one of the coldest planets in the solar system. To imagine being there is to imagine stillness. The sky would be a deep cyan fading to black. The sun, 20 times dimmer than it appears from Earth, would hang as a small, pale disk, bright enough to cast shadows, but too faint to warm. Around you, faint rings would glisten, and distant moons would drift like dust motes in slow motion. The silence would be total. Yet within that silence lies poetry, a planet tilted out of alignment, continuing on anyway, rolling gracefully around the sun, its long seasons unfolding with patience. Uranus reminds us that even when something is broken, it can still find balance, that there is beauty in what's different, and rhythm in what seems askew. If Jupiter is the drumbeat of the solar system and Saturn its melody, then Uranus is the quiet chord, in between soft, melancholic, and eternal. And beyond it, the final visible planet awaits a world of deep blue storms and supersonic winds, where Uranus drifts in silence, Neptune sings in turbulence. Let's drift onward to the farthest realm where sunlight fades into twilight, and the last giant stands watch at the edge of the solar system. At the edge of our planetary family, sunlight arrives like a fading memory, weak, distant, and slow. It takes more than 4 hours for a ray of light to reach Neptune, the farthest known giant. And yet, when it does, that faint light falls upon one of the most dynamic, restless worlds in the entire solar system. Neptune is the deep blue note at the end of the solar symphony, rich, cold, and endlessly moving. Where Uranus rolls in silence, Neptune sings in motion. Its atmosphere glows with a sapphire hue, more vivid than any other planet, colored by methane and fine atmospheric particles that scatter sunlight in shades of cobalt and indigo. Seen from afar, it looks like a smooth, tranquil orb. But up close, it is a world of storms and wind, the fastest ever recorded. Despite being the most distant major planet from the Sun, Neptune's winds howl at over 2,000 kilometers per hour, faster than the speed of sound on Earth. These gales sweep across vast, cloud-streaked bands, driving colossal storm systems that shift and vanish over weeks. The largest of these, the Great Dark Spot, was first seen by Voyager, 2 inches 1,989, a swirling oval nearly the size of Earth, rotating in Neptune's upper atmosphere. When telescopes looked again years later, it was gone, replaced by another. Neptune's storms live and die like waves on an invisible sea. What fuels such power so far from the Sun? The secret lies within. Neptune, like Jupiter and Saturn, radiates more energy than it receives. Deep inside, gravitational compression and slow contraction generate heat that rises upward, stirring its cold outer layers into motion. Beneath the visible clouds lies a mantle of water, ammonia, and methane ice, compressed into exotic forms, perhaps superionic water, where hydrogen atoms flow through a lattice of oxygen like lightning through a crystal. Below that, a rocky core sits under pressures millions of times stronger than Earth's. This inner heat gives Neptune its pulse, a slow, invisible heartbeat that drives weather unlike anywhere else. Its atmosphere forms streaks of white methane ice clouds, high and thin, moving faster than any storm on Jupiter. On the dark side, lightning flashes silently, illuminating the clouds in brief pulses. The planet rotates once every 16 hours, giving its winds a rhythm, a restless dance, beneath the faint glow of a distant Sunday. Neptune is surrounded by 6 faint rings, each composed of dark dust and icy fragments. They are incomplete and uneven, forming clumps and arcs rather than perfect circles. These arcs are kept stable by the gravity of nearby moons, a delicate balance where motion keeps chaos in check. And those moons, at least 14, known orbit like a scattered chorus, each one reflecting Neptune's strange magnetic beauty. The largest of them, Triton, is among the most remarkable bodies in the solar system. Triton orbits backward, opposite to Neptune's rotation, a clue that it was once an independent world, likely a captured object from the Kuiper Belt. This capture was catastrophic. It probably destroyed Neptune's original moons and altered its gravitational balance forever. Triton's surface is frozen nitrogen, gleaming pinkish white under the dim light of a faraway Sunday. But beneath its icy crust, evidence suggests there may be liquid water, an ocean kept warm by tidal forces and radioactive decay. Even now, cryovolcanoes burst from its surface, spewing nitrogen gas and dust into the sky, which then settles back as snow. Voyager 2 saw them plumes, rising 8 kilometers high, proof that Triton is still alive, geologically and thermally. The entire world exhales frost into space and inhales silence in return. Triton is not just a moon, it's a mirror of possibility, a hint that even in the coldest corners of the solar system, energy and motion endure. Voyager 2 remains the only spacecraft ever to visit Neptune. In August 1989, it swept past the planet at over 90,000 kilometers per hour, capturing shimmering images and faint radio whispers before continuing its journey outward into the dark. Its visit lasted just a few hours, the only close look humanity has ever had at this distant world. Since then, Neptune has waited, quiet but not forgotten, circling the Sun in a 165-year orbit. When it completes its next full revolution, centuries will have passed on Earth. To imagine drifting there is to imagine the edge of warmth. The Sun appears as a bright star, not a disk, casting twilight across an endless sea of blue. The wind hums, but you cannot hear it. Above, the faint rings shimmer like glass dust. Below, clouds roll and break, their shadows fading into depths we cannot see. If you look down from orbit, you'd see Triton gliding slowly beneath you, its frozen geysers rising and falling in the stillness, like breaths on a winter window. Neptune marks not an end, but a threshold, the frontier where sunlight fades and the solar system gives way to deep space. Beyond its orbit lies the Kuiper Belt, a vast, icy realm of dwarf planets and comets, where Pluto, Eris, and countless smaller bodies drift through the cold. Neptune's gravity shapes that region, guiding these faraway worlds in long, looping paths. Even now, Neptune's faint blue light reaches us across billions of kilometers, delayed by more than 4 hours ancient sunlight reflected from methane clouds and frozen winds. When you look at it through a telescope, you are seeing light that left that world when it was still turning beneath a different storm. Neptune teaches us that the universe doesn't grow empty, only quieter. It is a reminder that even at the limits of warmth and light, beauty persists. Its winds may rage, but its colors soothe the paradox written in air and time. And as we drift past Neptune into the great expanse beyond, the planets fall behind us one by one, until even the Sun becomes a distant spark. Ahead lies a deeper darkness, the frozen frontier of dwarf planets, comets, and the mysterious Oort cloud. Our journey through the planetary realms is almost complete, but the solar system still whispers in the dark. Beyond Neptune, the night begins to glow again, not with heat, but with memory. Beyond Neptune, the solar system does not end. It fades. The light weakens, gravity softens, and the great clockwork of planets gives way to a realm of silence. Out here, space becomes a museum of ice, filled with forgotten worlds that never grew large enough to be called planets. This is the Kuiper Belt, a vast ring of frozen bodies circling the Sun like a halo of ghosts. The Kuiper Belt stretches from about 30 to 50 astronomical units, away tens of billions of kilometers from the Sunday. If Earth's orbit were a single step, Neptune would be 30 steps away, and the Kuiper Belt would begin just beyond that, a wide field of icy fragments orbiting in slow, endless loops. Each fragment is a relic of creation, unchanged since the solar system was young. Here, sunlight is so faint it feels like twilight even at noon. The Sun would appear as a bright star, its warmth barely reaching your face. The darkness is not empty, though it glimmers. Tiny ice particles catch what little light there is, reflecting faint blues and silvers into the black. This is the cosmic frontier, where time moves differently, slower, quieter, eternal. The most famous of these distant wanderers is Pluto. Once called the 9th planet, it now holds a new title, dwarf planet, not a demotion, but a redefinition. Pluto is a world of paradoxes, small yet complex, frozen yet alive with motion. It is only about 2/3 the diameter of Earth's moon, yet it has mountains of solid water ice, plains of frozen nitrogen, and a thin, delicate atmosphere that breathes in and out with its seasons. When Pluto moves closer to the Sun in its elliptical orbit, sunlight warms its surface, and its ices vaporize into a thin haze that drifts into space. As it drifts farther away again, the atmosphere freezes and falls like snow, coating the world in a new layer of frost. Every 248 years, Pluto exhales and inhales an entire atmosphere born and buried with the rhythm of its orbit. On Pluto's surface lies a bright, heart-shaped plane called Sputnik Planitia, discovered by the New Horizons spacecraft in 2015. It is not just a patch of ice. It may mark the top of a subsurface ocean, still liquid beneath kilometers of frozen nitrogen. This hidden sea might be kept warm by radioactive heat from Pluto's rocky core, insulated by layers of ice. Even here, more than 5 billion kilometers from the Sun, water may still flow slowly, silently, eternally. Pluto is not alone. It travels with a companion Charon, its largest moon, so big that the two actually orbit a shared center of gravity outside of Pluto itself. Charon's surface is scarred by massive canyons and stained with dark tholins, organic compounds created by sunlight and cosmic rays. The two worlds face each other in eternal lockstep, bound forever by gravity and shadow, like twin lanterns drifting through the dark. Beyond Pluto, more worlds wait. Eris, slightly smaller but denser, glinting with an icy surface that reflects 96% of sunlight, brighter than fresh snow. Haumea, elongated by its rapid spin, surrounded by its own faint rings. Makemake, reddish and lonely, with a thin halo of methane frost, and countless smaller bodies, each one a frozen time capsule from the dawn of creation. These dwarf planets are ancient embryos, the beginnings of worlds that never finished forming, locked in distant orbits, untouched for billions of years. They preserve the solar system's childhood in ice and dust. Scientists study them to understand how the planets began, how dust became rock. Rock became planetesimal, and planetesimal became world. If you were to drift among them, you'd see sunspark ice fields stretching for light hours, fragments tumbling slowly through eternity. Some would be smooth spheres of frozen methane, others jagged shards, half lit by the distant Sunday. Between them, the temperature hovers near 240 degrees Celsius, cold enough to freeze even nitrogen solid. Yet even here, life's ingredients exist: carbon, hydrogen, oxygen, nitrogen, and traces of complex organics. The raw chemistry of everything we know is scattered like dust in the dark. The Kuiper belt ends gradually fading into the scattered disk, where objects follow elongated, tilted orbits shaped by Neptune's pull. Some stretch so far into the void that they take thousands of years to return. Beyond even these, at the limits of our imagination, lies the Oort cloud, a vast, spherical shell of icy bodies, perhaps trillions of them, surrounding the entire solar system like a distant halo. No one has ever seen the Oort cloud directly. It exists as a theory, inferred from the behavior of long-period comets that fall toward the Sun every few millennia. These comets are wanderers from the edge, ancient debris shaken loose by passing stars or galactic tides. When they fall inward, they light up, forming bright tails that always point away from the sunlight sculpting ice into luminous wind. Some of those comets may have brought water and organic compounds to Earth billions of years ago, helping to seed the oceans and, perhaps, life itself. In that sense, the cold outer reaches of the solar system are not merely dead. They are the origin of everything living. The edge of darkness gave birth to the light of consciousness. If you floated there, among the drifting bodies of the Kuiper belt, you'd see the Sun as no larger than a star bright, but no longer warm. Yet still, it would glow, casting faint shadows on the icy plains below. Every glint and sparkle around you would be sunlight, ancient, patient, and enduring. Out here, time expands. Orbits stretch for centuries. A single season might last longer than the entire span of human history. The silence is total, but not empty. It hums faintly with radiation, dust, and distance, the soft static of eternity. The solar system does not truly end at the Oort cloud. Its gravity reaches still farther, fading but never vanishing, holding onto comets a light year away. Beyond that boundary lies interstellar space, the sea between stars, filled with invisible currents of gas and dust, magnetic fields, and the faint glow of cosmic rays. Our journey began under the warmth of the Sunday. It now drifts toward the threshold where that warmth ends. But the story isn't over, because even as we leave the last planet behind, humanity has already sent its messengers into that deep night. They travel still, carrying our songs, our greetings, and the sound of waves against an unseen shore. Next, we follow them beyond the sun's domain, into the great, starless expanse. Past the last whisper of the Kuiper belt, where dwarf planets fade into pinpoints of ice, there lies no edge, only distance. Here, the sun's light weakens into a ghost, and its wind, that invisible stream of charged particles flowing outward through the solar system, begins to falter. This boundary, called the heliopause, marks the final breath of the Sunday. Beyond it lies interstellar space, the realm between stars. Imagine floating there, at that invisible border. Behind you, the planets orbit quietly like lanterns arranged in concentric circles. Before you, there is only dark. A dark, not of emptiness, but of depth, filled with the thin dust and faint magnetic whispers of the galactic sea. You are standing on the threshold of home and infinity. The heliosphere, the sun's magnetic bubble, stretches for billions of kilometers in every direction, a shield that protects the inner worlds from cosmic radiation. It is not static but breathing, expanding and contracting with the rhythm of the solar cycle, pulsing every 11 years as the sun's magnetic field reverses its polarity. Inside it, the solar wind reigns. Outside it, the interstellar medium begins the tenuous blend of hydrogen, helium, and stardust that fills our galaxy. Crossing this line is not like stepping off a cliff. It's like passing from one current into another. The particles around you shift, their direction changes, and the sun's voice grows faint still there, but muted, like sound through fog. In 2012, Voyager 1, launched in 1977, became the first human-made object to cross that boundary. For decades, it had traveled outward, past Jupiter's storms, Saturn's rings, Uranus's tilt, Neptune's winds, and into silence. Then, its instruments recorded a sudden change. The solar wind stopped, and the surrounding particles no longer flowed outward from the sun, but inward, from the galaxy itself. Voyager 1 had entered interstellar space. It is now over 24 billion kilometers from Earth. Every signal it sends, a faint radio whisper, powered by the warmth of decaying plutonium, takes more than 22 hours to reach us. And yet, it still speaks. It tells us of temperature, density, and the hum of distant particles, the weather of the galaxy. Its twin, Voyager 2, followed 6 years later, crossing the same frontier in 2018. Together, these two small spacecraft have become humanity's quiet ambassadors, drifting through the dark beyond sunlight, carrying with them a message etched in gold. Attached to each Voyager is a golden record, a phonograph disc plated in gold, designed to last 1 billion years. On it are the sounds of Earth, a baby's cry, a heartbeat, the crash of waves, the songs of whales and birds, greetings in dozens of languages, and music from Bach to Chuck Berry. It is a time capsule, a love letter, a declaration. We were here. If someday, perhaps millions of years from now, another civilization were to find it, they would hear the sound of rain, of laughter, of thunder, over the sea, the music of a planet alive. They might never know our names, but they would know our voice. The voyagers are still within the sun's gravitational reach, but not its warmth. They drift through a region called the local interstellar cloud, a sparse veil of gas and dust about 30 light-years across. The solar system itself sails through this cloud, like a ship through fog, shielded by its fading magnetic wake. Every year, the voyagers move farther, tracing a slow spiral outward as the sun carries them through the galaxy. In a few tens of thousands of years, they will pass near other stars, dim red dwarfs, cold suns with their own families of planets. Long before then, their power will fade. Their instruments will fall silent. They will continue to drift, inert, eternal, carrying within them the first human-made symbols to leave the solar system. They are not fast by cosmic standards. To reach the nearest star, Proxima Centauri, would take them over 70,000 years. Yet their journey is not about arrival. It is about endurance. They are messages written in persistence. From the voyager's vantage point, the sun is no longer a blazing star but a small white dot, one among hundreds of billions. The planets are invisible. The warmth that once shaped them no longer matters here. Beyond this distance, there are no orbits, only trajectories. Still, even here, the sun's gravity holds sway, faint but infinite. The Oort cloud stretches nearly a light-year away, marking the true edge of its dominion. Comets within it drift like ancient pilgrims, frozen and slow. Sometimes, one is nudged by the pull of a passing star, beginning a journey inward, a long fall that may take millions of years before it flares briefly near the sun and vanishes again into the dark. In that sense, the solar system never ends. It just becomes thinner, quieter, more dreamlike. The sun's light continues, growing fainter but never disappearing, like a candle seen from across an ocean. And here, amid the emptiness, something profound happens. The perspective shifts. The sun becomes just another star. Earth becomes one of countless worlds. From this distance, our entire civilization, our oceans, our storms, our songs, all collapse into a single point of light, pale and fragile, yet radiant. As Carl Sagan once said of that view, the Earth is a very small stage in a vast cosmic arena. Every conflict, every love, every generation that ever lived, all of it happened on that dot. The farther we travel, the more it shines not as a place, but as a memory, a tiny shimmer of life in an endless night. The voyagers are still moving, and so are we in thought, in exploration, in hope. One day, new probes will follow, faster and wiser, carrying our understanding farther. But the first two will always be our trailblazers of silence, the instruments that carried humanity's heartbeat past the reach of the Sunday. As we drift now, beyond the heliopause in our imagination, the universe opens around us, not empty, but filled with potential. Ahead lies the Milky Way's slow spiral. Billions of stars, each with its own story, its own worlds, its own chance to glow. And so we leave the solar system, not as an ending, but as a continuation. The darkness ahead is not void, it is beginning. Next, we will turn back, one last time, to the sun itself, the star that started it all, and listen to its quiet, rhythmic hum as it breathes light into the cosmic sea. Every story in our solar system, every wind, tide, storm, and orbit begins and ends with the Sunday It is our origin and our anchor, the quiet fusion engine that breathes warmth into a frozen universe. Without it, there would be no blue skies, no oceans, no green valleys, no light to stir the first cells into motion. Every dawn, every heartbeat is powered by its fire. And yet, for all its brilliance, the sun is humble, one star among hundreds of billions, modest in size and age. But to us, it is everything. From a distance, it glows as a steady, golden sphere. Up close, it is a roaring sea of plasma, boiling and alive. The sun's heart is its core, where gravity crushes hydrogen atoms together until they merge into helium, releasing light and heat. Each second, more than 4 million tons of matter vanish into pure energy, a steady sacrifice that fuels the solar system. The light from that fusion takes thousands of years to journey outward, bouncing through dense layers of gas before finally escaping into space. From there, it travels at the speed of light, crossing the void to touch Earth 8 minutes later, the warmth on your skin, a message from the sun's heart, written long before you woke this morning. At the surface, the photosphere, the temperature falls to about 5,500 degrees Celsius, and the plasma churns in granules like golden boiling water. Above it lies a layer of glowing hydrogen called the chromosphere, and beyond that, the corona, the sun's outer atmosphere, which blazes at over 1 million degrees. For centuries, that mystery puzzled astronomers. How could the outer layer be hotter than the surface below? We now know it may be heated by magnetic waves and bursts of energy called nanoflares, rippling upward from the sun's tangled magnetic fields. The sun is not calm. It breathes in cycles. Every 11 years, its magnetic poles flip north, become south, and south becomes north. During these solar cycles, dark sunspots blossom across its surface, cooler regions where magnetic energy builds up. Sometimes, that energy releases in an instant, producing solar flares or coronal mass ejections, immense explosions that hurl billions of tons of charged particles into space. When these reach Earth, they stir our planet's magnetic field and light up the skies with auroras, shimmering curtains of green, pink, and violet that ripple near the poles. Though we see them as beautiful, they are a reminder of the sun's power. The same radiation that paints the sky can also disrupt satellites, radio waves, and electrical grids. Our civilization, every phone call, every GPS signal, every light, depends on a star that can whisper one moment and roar the next. Still, for all its violence, the sun's warmth has been remarkably steady. Over billions of years, it has brightened only slowly, giving Earth time to evolve oceans to form, life to arise, and intelligence to wonder about the source of its light. Deep within, the fusion continues. Gravity presses inward, energy pushes outward, and the two forces balance in perfect equilibrium. That balance is what keeps the sun shining, a cosmic heartbeat that has endured for 4.6 billion years. But like all stars, the sun is mortal. In about 5 billion years, it will begin to change. When its hydrogen runs low, fusion will slow, and gravity will gain the upper hand. The core will contract and heat until helium itself begins to fuse into heavier elements, carbon and oxygen. The outer layers will swell, and the sun will become a red giant, engulfing Mercury and Venus, and perhaps even Earth. For a brief time, the sky from Earth's orbit will blaze with crimson fire, the airless beauty of a world inside a dying star. When the helium is exhausted, the outer layers will drift away into space, forming a glowing shell of gas, a planetary nebula, a cosmic blossom expanding through the dark. At its center will remain the core now, a dense, white, hot, ember, about the size of Earth, but half the mass of the Sunday. This is the white dwarf, the Sun's final form. It will no longer burn, but it will glow for trillions of years, cooling slowly as it fades. Long after the galaxies themselves have changed shape, that white dwarf will still carry the memory of sunlight, the echo of the warmth that once filled the solar system. Every atom of carbon in your body, every breath you take, comes from stars that lived and died like this. The sun is part of that lineage, one note in an eternal cycle. Stars form, burn, collapse, and seed new worlds. We are not separate from that rhythm. We are its continuation. The gold in our jewelry, the calcium in our bones, the oxygen in our blood, all were forged in the hearts of long-dead stars. We do not merely orbit the Sunday. We are the sun, rearranged into thought. And even as it burns, the sun hums. Its surface vibrates with low-frequency oscillations, pressure waves that ripple through its body, like the sound of a colossal instrument. Scientists study these tones through helioseismology, turning them into audible frequencies. If you could hear the sun, it would not roar, it would resonate, deep and harmonic, like the breathing of a giant asleep. To drift near it would be to see constant motion arcs of fire taller than planets, waves of plasma tracing magnetic loops thousands of kilometers high, and rivers of light folding over themselves in golden silence. Yet from Earth, all of that chaos softens into warmth, gentle, life-giving, familiar. Each sunrise is a reminder. You live by the grace of a thermonuclear storm, and yet you wake to it as to a friend. So tonight, as you lie under the same starlight that crosses the emptiness of space, remember this: the warmth that touches your skin began in the heart of the sun before the first humans ever walked the earth. And one day, when the sun becomes a faint ember, the particles that were once part of you will drift among the stars, carrying that same light onward. The sun will fade, but its story, our story, will continue, because light never truly dies. It only travels. Next, we'll return home to Earth, the small blue thread that binds every planet's story together, and the place where starlight became life. We began this journey in the heart of the sun, where light is born. Now, after drifting through all the planets and the dark between them, we return home to the one place where that light learned to think, to breathe, to dream. This is Earth, the quiet miracle of the solar system, the only world we know that looks back at the stars. From afar, it glows softly, a blue marble, wrapped in swirling white clouds, floating in the black sea of space. The first humans to see it from the moon said it looked fragile, almost delicate. Against the vastness of the cosmos, it seemed impossibly small. And yet, within that tiny sphere, lies every story ever lived, every ocean, every mountain, every whisper of wind and word. Earth is a planet of balance, warmth and cold, motion and stillness, order and chaos. It is not the biggest nor the brightest, but it is the most alive. Its orbit tilted just enough. Its atmosphere dense enough to cradle water. Its magnetic field strong enough to shield against the solar wind. All these quiet coincidences align to create a rare equilibrium. At its heart lies an iron core, rotating within molten metal, generating a magnetic field that stretches into space like an invisible cocoon. Above it, continents drift slowly across a mantle of hot rock, their collisions raising mountains and shaping oceans. The planet's plate tectonics recycle carbon and stone, stabilizing temperature over billions of years. The air we breathe, oxygen, nitrogen, and water vapor, is both product and protector of life. And then, there is water, the great transformer. Earth is the only known world where water exists naturally in all three states: solid, liquid, and vapor. Ice glitters at the poles, Oceans shimmer with motion. Clouds drift through the sky, falling as rain and rising again as mist. Water is the planet's memory it carries. Heat, sound, and history. It shaped the land, carved the canyons, filled the valleys, and gave rise to the first cells that would one day name the stars. Every living thing on Earth carries the signature of the cosmos atoms forged in ancient suns. But here, they assembled into something more. Consciousness. From bacteria to forests, from coral reefs to human eyes, Earth is the universe turning toward itself in wonder. The biosphere, that thin, shimmering layer between ocean and atmosphere, is a miracle of cooperation. Trees inhale carbon dioxide and exhale oxygen. Oceans absorb light and exhale clouds. Even bacteria beneath the soil release gases that shape the weather. The entire planet breathes, in slow, rhythmic cycles, like a single vast organism. From space, you can see those breaths. The northern, after drifting through storms of gas, rings of ice, and the cold silence beyond Neptune. Coming home feels like returning to a dream. In the vastness of the solar system, Earth is so small, it almost disappears, a pale blue flicker wrapped in clouds. And yet, from that tiny sphere comes everything we know of color, sound, and thought. It is the only place where the universe has opened its eyes and looked back at itself. From space, Earth glows like an opal blue oceans, white swirls of cloud, hints of brown and green beneath the mist. It's easy to forget that this shimmering jewel is not static. It is alive. Air moves. Water flows. Continents drift. The planet breathes through forests and waves. It pulses with sunlight and shadow. Earth is the only world we know that holds liquid water on its surface, not frozen into glaciers or locked beneath crust, but flowing freely. Oceans cover more than 70% of its face, shaping the air and reflecting the sky. Their rhythmic tides follow the pull of the moon, rising and falling like the planet's heartbeat. Beneath those waters, life began single cells drifting in ancient seas, feeding on chemical warmth. Over billions of years, those cells learned to use light, capturing photons from the sun and turning them into food, releasing oxygen as a byproduct. That single chemical trick, photosynthesis, transformed the planet. It filled the sky with breathable air and painted the world green. The atmosphere that formed became a veil of protection, a magnetic shield deflecting solar radiation, a blanket holding warmth. Without it, the oceans would freeze and the winds would strip away the surface. With it, the planet could dream. Earth's crust floats on molten rock, shifting slowly over time, a process called plate tectonics. These movements build mountains, open oceans, and recycle carbon through the air and stone. It is a constant renewal, destruction and creation intertwined. No other planet we know does this. On Earth, even the ground beneath your feet is alive with motion, a slow geological rhythm that never stops. From those first oceans came corals, fish, forests, insects, dinosaurs, and finally us. Each new form of life was a variation on an ancient theme, molded by sunlight, water, and time. We are not separate from that lineage. The calcium in our bones was drawn from the sea. The iron in our blood was forged in stars. The oxygen we breathe was exhaled by trees. When astronauts first saw Earth from space, they described a feeling they could not name, a deep awareness of connection. They called it the overview effect, the realization that every border, every division is invisible from up there. From orbit, there is no us and them, no lines of nation or race, only one glowing sphere of life, adrift in blackness. Every rotation brings day and night. Every orbit brings seasons, each one shaping life in cycles. The tilt of Earth's axis, about 23.5 degrees, gives us spring's renewal, summer's abundance, autumn's fading, winter's rest. It is a perfect balance of warmth and coolness, of change and return. Without that tilt, there would be no rhythm to life, no migrations, no growing seasons, no beating pulse of renewal. And above all, there is light. Every morning, the sun rises again, the same light that touched the newborn Earth 4.6 billion years ago. It scatters through air and water, bending into blues and golds. It nourishes leaves, warms oceans, and fuels the dance of weather. It is the most ancient story the planet knows, energy transforming into life, endlessly. Even the air you breathe carries memory. Each breath contains molecules once exhaled by trees, whales, and ancient volcanoes. Some atoms in your lungs have passed through the veins of dinosaurs, drifted in clouds above deserts, frozen in glaciers, or burned in stars. Every inhalation is an inheritance, the universe, recycled through you. Earth's magnetosphere hums around it, a shield of invisible power born from molten iron in its core. Without it, the solar wind would strip away our atmosphere as it did on Mars. But here, that same wind is caught and shaped into light auroras dancing over the poles, shimmering green and purple like curtains of breath. This planet is not quiet. It speaks in waves, wind, thunder, and the whisper of trees. Each sound is an echo of energy, transformed heat into motion, motion into sound, sound into silence again. Even when you lie still and listen at night, the world continues. Insects clicking, oceans sighing, Earth spinning beneath the stars. From space, the night side of Earth glows faintly with the lights of cities, tiny constellations of civilization, pulsing with the same curiosity that sent Voyager into the dark. We are starlight, building lanterns against the void, and yet Earth remains fragile. A thin atmosphere, a delicate balance of warmth and water, a single distance from the sun where ice melts but oceans do not boil. Shift that balance even slightly, and the whole system trembles. The more we learn about other worlds, Venus scorched, Mars frozen, the more we understand how rare this equilibrium is. Earth is not the center of the universe, but it is the center of our universe, the cradle of everything that has ever loved, dreamed, or hoped. When you step outside at night and look up at the stars, remember, you are looking out from the only known shore of life. The dust beneath your feet and the light above your head are made of the same things. Perhaps the greatest wonder of all is that we are aware of it, that stardust can think, feel, and look back at the sky that birthed it. In every human gaze upward, the universe contemplates itself. So, as we return to this world, our blue home, let the noise of the day fade, and feel the quiet pulse beneath it all. The rivers, the tides, the air, the slow movement of continents, they are all part of the same song, one written by the sun and sung by the earth. And in that rhythm, we find rest. The solar system turns, the stars move, time flows like light, and we, the children of dust and flame, drift gently within it, breathing the sun, dreaming the cosmos. Every cycle must end, even the story of sunlight. The earth turns, the planets move, and the stars drift through the slow tides of the galaxy. The same rhythm that began with a spark will one day fade into quiet again. But endings, in the language of the cosmos, are never truly final. They are transformations, the way light changes form, the way matter folds back into memory. For now, the solar system still dances. Jupiter's storms still rage. Saturn's rings still shimmer. The Earth still breathes in green. But above and around all of it, the Milky Way continues its grand orbit, carrying our entire system through space at nearly 800,000 kilometers per hour. The sun itself is moving, circling the galactic center, once every 230 million years. In that time, continents rise and vanish, species bloom and fade, and mountains erode into sea. The stars that share this journey are our galactic companions, drifting in formation through the dark. The Milky Way is a spiral of 200 billion stars, a glowing whirlpool of dust and gas, stretching more than 100,000 light-years across. Our solar system lies in one of its quiet arms, far from the crowded, violent center. That distance is a gift. Here, the light is calm enough for life to thrive, the radiation low enough for memory to persist. But galaxies, too, are alive, moving, colliding, reshaping. In 4 billion years, the Milky Way will meet its neighbor, Andromeda. The two will merge slowly, stars passing like ghosts, gravity weaving them into a single new galaxy, Milkdromeda. The sun will still exist then, swollen and red, perhaps surrounded by the ghosts of its planets. From whatever fragments remain, the night sky will blaze with unfamiliar constellations, two spirals becoming one. Long after that, when even the merged galaxy grows old, the light will dim. Stars will exhaust their fuel and fade into embers, white dwarfs cooling into black dwarfs, neutron stars slowing their spin, black holes swallowing what remains. It will not be a death, but a long exhalation, the quieting of the cosmic symphony that began with the Big Bang. And yet, in that silence, new things may still stir. Quantum sparks may flicker in the dark. Matter may collapse and bloom again. The universe has a way of remembering itself. It is humbling to think that the same atoms in your hands, the same molecules in your breath, will one day drift between galaxies. You are already part of that journey, every heartbeat, every breath, powered by sunlight that began its path in the heart of a star. When your body returns to the Earth, those particles will move again through soil, water, air, and time, eventually leaving this planet to join the cosmic dust that builds new worlds. In that sense, you are not a visitor to the universe. You are the universe, briefly aware of itself. You are the continuation of the same process that forged stars, planets, oceans, and life. The same physics that ignited the sun and cooled the moon. Every thought you have is a transformation of ancient light. And maybe that's the secret of the sleepy science way of seeing things, not to chase the universe as something distant and cold, but to feel its warmth inside your own pulse. The stars are not out there. They are within you. When you look at the night sky, you are not looking up. You are looking back in time, through layers of history written in photons. Some of the stars you see have already died, their light only just arriving. Every glimmer is an echo of something that once burned, bright proof that light can outlive its source. One day, our own light will become that echo. The sun will fade, the earth will cool, but somewhere, maybe on a distant world, maybe in another galaxy, someone will look up and see a faint shimmer. A photon that once warmed our oceans, once fell through a leaf, once touched your skin still traveling. And if that traveler has eyes to see and wonder to feel, then the story continues. Because the universe's truest law isn't entropy or decay, it's persistence. Light travels on, memory endures, energy transforms, but it is never lost. So rest now, knowing that everything that ever was is still here, rearranged, reborn, remembered. The stars will sleep, the galaxies will fade, but the quiet glow of existence will remain, humming softly beneath time. Let that thought carry you to stillness. You are part of the light. You have always been part of the light. And when you sleep, the universe sleeps with you, gentle, infinite, and endlessly awake. Silence, not the kind that follows a sound, but the kind that existed before any sound at all. The deep quiet that filled the cosmos before stars began to burn. And in that silence, something still moves. It's not gone. It only rests. Every atom, every flicker of light, every current of gravity still hums softly, like the low breath of a dreamer asleep. Time itself slows here, stretching into something vast and gentle. If you could stand within that final stillness where galaxies have dimmed and the last stars have cooled to dark embers, you would not see emptiness. You would see memory. The universe keeps everything. The ashes of stars, the vibrations of gravity waves rippling through the dark, the trace of photons that once warmed oceans and touched eyes, even the faint pulse of thoughts, the stories of beings who once wondered where they came from. Somewhere, those traces still move through the dark like whispers. A golden record spins silently through space, carrying laughter, music, and rain. A single photon from the last sunset over Earth drifts toward another galaxy. A handful of dust from your skin mingles with the particles that will one day form new suns. The cosmos, in its endless patience, is not a machine. It is a story one written in light. Every world, every life, every heartbeat has been a single line in that story, a note in its slow, eternal song. And when all the notes fade, what remains is harmony, a field of quiet energy, smooth and unbroken, from which everything once rose and may rise again. Perhaps, in some far future, beyond any scale of time we can imagine, the universe will stir once more. Tiny quantum ripples will flicker in the stillness, giving birth to new sparks, new space, new stars. A new dawn will unfold, and the cycle will begin again, creation breathing itself back into existence. Until then, what remains is peace, because nothing in the universe is ever truly lost. Every collapse is a preparation for expansion. Every darkness hides the potential for light. Every ending carries within it the seed of beginning. So, as this story closes, let yourself drift, not away, but inward. Feel the pulse beneath everything, the same rhythm that turns galaxies, stirs tides, and beats within your chest. That is the universe dreaming through you. And as you sleep, remember, you are made of the same light that built the stars. You are not a small thing in a large cosmos. You are the cosmos, briefly remembering itself. Rest easy, little fragment of infinity. The story continues softly, eternally, everywhere.